Okay, the following is a video over 1-3 notes, and this is distance and midpoints. This is a very, very powerful tool that we'll use in geometry. So let's get started. A distance, well, that is a length between 2 points. Okay, and so what we use primarily is just kind of counting the space between the numbers allows us to find vertical distance and horizontal distance. I'm sorry, vertical distance and horizontal distance. And so what we're trying to find is the distance between, say, 2 points, like the, say, point 1, 1 and 4, 5. Okay. And so what we could typically use is the Pythagorean theorem. And so, guys, I have a friend in my life, and that friend is named Pythagoras. He's always there for you. He's never going to, suddenly tell you that something suddenly came up and he can't hang out with you anymore Friday night. So, besides that, Pythagorean theorem is the given a right triangle. Okay, we calculate this length C using side lengths A and B. Okay, so if this is a right triangle, then we know that by Pythagorean theorem that A squared plus B squared is equal to C squared. Okay, so my friend Pythagoras. So Pythag or S. All right. And so what I want to do, let's take a look at the distance between the points 1, 1 and the point 4, 5. Okay, and so what I would do, trying to find the length between this point here and this point here, and I'm just going to go ahead and call this, oh gosh, yeah, point A and point B. Okay, we want to find the distance between point A and B. So I'm going to write that over here. AB is equal to. Okay, and so I'm going to also draw a point right here because that is directly across or horizontal from A. Okay, and then I'm going to draw a line from point B down to this point because it's directly above. Okay, and I've drawn a right triangle here. So if I go in and signify that, and I'm going to call this point right here point C. Okay, so I know the length from A to C, okay, because that's the length of 3. The distance between 1 and 4 is the length of 3. Okay, and then the length of CB is 1 to 5. Okay, and so that the length between 1 to 5 is 4. All right, and so I'm going to go over here and I'm going to say, okay, AC is equal to 3, and I'm going to say that BC is equal to 4. Okay, I'm curious to know what AB is equal to. All right. So, but what I know by the Pythagorean theorem is I can figure that out. Okay, I can set this equation up. And I'm going to go ahead and call this distance D. Okay, it's length AB, but I'm going to assign it a length variable of D. All right, so I know that if I take D squared and set it equal to 3 squared plus 4 squared, okay, and guys, this is the same thing as Pythagorean theorem, except I'm using the variable D instead of C here. And so if I actually solve for D, I can take the square root of D, square root of both sides, and I get square root of 3 squared plus 4 squared. Okay, so let's simplify this, and I get D is equal to the square root of, say, 9 plus 16. Okay, and so then D is equal to the square root of 25. All right, and we know the square root of 25 is just 5. Okay, so D is equal to 5, all right? So then that means that the length AB is a measure of 5 units. And guys, this is a 3, 4, 5 triangle. I am going to talk about the 3, 4, 5 triangle all year long. So get used to it because it's awesome and it's cool and it's got a lot of significant value in history. So, but besides that, we can figure out the distance between 2 points using the Pythagorean theorem. Okay, another way that we can think of that is by using the distance formula. Okay, I'm going to go ahead and call this x sub 1 and y sub 1. I'm going to call this x sub 2 and y sub 2. And I'm just giving my x and y values just generic names. Okay, this is my first x value. This is my second, or my first point, and this is my second point. Okay. And so what I can do is I kind of want to use this, all right? And I'm going to use this, I'm going to rewrite this over here. I'm going to say d is equal to the square root of 3 squared plus 4 squared, okay? And what I want to do is I want to rewrite 3. We got to think about how did we get 3, all right? That's the distance between 1 and 4, okay? So by using those numbers and using some arithmetic, I can rewrite 3, and let me do this, rewrite 3 as the subtraction of 4 minus 1, okay? The difference between 4 minus 1, squared. Okay, I've just rewritten 3 as 4 minus 1. Plus, let's do the same thing for 4. How did we get 4? Well, we took 5 minus 1, and that gave us 4. So we take 5 minus 1 and square that. Okay, well, let me rename this, all right? If I rename these points, well, 4, that's x sub 2. Let me write this next step. D is equal to the square root of the quantity. Okay, 4. Now, 4 is x sub 2. Okay, minus 1. Well, that was just x sub 1. X sub 1, quantity squared, plus, and then let's take 5, that's y sub 2, and let me subtract off 1, which is y sub 1, okay, and let me square that, and guys, what I have here is a formula, okay, and this formula will work with any 2 points, okay, and so you can use this, and you can just plug in the points. I would name them first and just plug them in, or you could use Pythagorean theorem. Now, they are the same thing. You will get the same answer of 5, okay? However, one might be easier for you, okay? Maybe you just like to plug it in and just evaluate. Maybe you need to actually plot the points and then, evaluate it, okay? So both ways. I like doing it this way because I have a friend, and his name is Pythagoras, okay? All right, so moving on, we've got the next thing which is called the midpoint, okay? And the midpoint is a point that divides a segment into 2 congruent segments. Okay, and so a midpoint is pretty much just what it says. It is the middle point between 2 points. Okay, so it takes a segment and divides it, that segment into 2 congruent segments. Okay, so let's just plot a couple points here. I'm going to plot the point 2, 1, and I'm going to plot the point 4, 5. Okay, and so I'm going to go ahead and do that here, 2, 1, and then 4, 5. Okay, and I'm going to connect those, and I'm going to call those points C, or yeah, no, let's see. I'm going to call it point D, call this point E, all right? So I'm going to connect those with the line segment. Go ahead and do that. All right, and I don't really know the length of this line, so to speak. We could figure it out using my friend Pythagoras. He's got a great idea. He's got some theorem that he uses. But I'm not really concerned about necessarily the length of it. I'm concerned more about what point is in the middle. And you can kind of just look and see, and if you kind of use the concept of slope, you can go up 2 over 1, up 2 over 1. And this gives me, the midpoint as well, okay? But I actually want to figure out this point. Now we know the point, we know the midpoint is going to be, what is that, 3, 3? Okay? And so, we can, well, let's just see how we can figure that out. Okay, if I draw another right triangle, okay, if I draw a line going down from point E, and I draw a line going over from point D, and if I count these, or if I look at the length here, okay, I can look. I know this is a length of 2. I'm gonna call this F. Call this F. Um, I look at this length between point 2 and point 4, okay, and this is a length of 2 units. Something that would divide that into 2 congruent pieces is the middle point right here, which is at 3, okay? And so that is also just vertically down from the midpoint that we had described, okay? If I look at EF, that's a length of 4, okay? And I can cut my midpoint right here, and I can get 2 and 2 congruent pieces, and that's directly to the right of our midpoint, all right? So what I can do is I know that between 2 and 4, 3 is the middle number, okay? Between 5 and 1, 3 is the middle number, okay? So how do I get these numbers, okay? How do I get 3 by taking 2 and 4? And I'm talking about the middle. And when I'm talking about the middle, I'm really talking about an average, okay? So if I were to average my two x values, okay, if I took 2 plus 2 and divided, I'm sorry, 2 plus 4, 2 plus 4, taking my two x values and dividing them by 2, I would get 6 over 2, which is equal to 3. And that's my x value, okay? That's the x value of this point, 3, 3, okay? Now, let's take a look at 1 and 5. Let's do the same thing for those. So if I take 1 plus 5 and divide it by 2, I end up getting the same thing. Okay, I get 6 over 2, which is equal to 3. Okay, and that's my y value. Okay? So what I can do is I can kind of do the same thing I did with the distance formula, and I can just apply these generic values. Like I can call this x sub 1 and y sub 1. I can call this x sub 2 and y sub 2. All right? And so I can rewrite this formula. I'm going to write it in the form of a point, okay? And I'm going to write it as, instead of writing 2, I'm going to write x sub 1. Okay, instead of writing 4, I'm going to write x sub 2, so plus x sub 2, all over 2, taking two numbers, adding them together and dividing them by 2, finding the average. Okay, and I'm going to do the same thing for y. So if I got 1, I'm going to replace it with y sub 1. So I get y sub 1, and then plus 5, which is y sub 2, divide that by 2, and that's my y value. Okay, this means my x value, this is my y value. And I get 3, 3, and that's what I had here and here. Okay, I'll do a lot of examples over this, but I do want to stop the video and then be able to continue on. Okay, so it's going to be a two-part note, and then that's fun. Okay, this is non-negotiable. We are having fun, whether you like it or not. At least I'm having fun. Enjoy it. Have a good time.